Let's be real, if you've ever felt the absolute dread of deploying code to production, you're going to love what we're diving into today. In this explainer, we're building a production-ready CI/CD pipeline from absolute scratch. We're going to take that messy, stressful process and automate literally everything using GitHub Actions. Think about the old way of doing things. You know the drill. SSHing into a production server, manually pulling the code, waiting for dependencies to install, restarting the service, and then you cross your fingers and just hope it doesn't break. It's so tedious, right? It's a total recipe for human error. But the new way? It's literally just a single git push, one automated command that completely replaces all that manual anxiety. Because here's the core problem with that manual SSH and pray method. When you deploy manually, you're basically asking a human being to repeat this exact sequence perfectly every single time for every deploy forever. And let's face it, we aren't built for that. We're going to forget steps, we'll skip tests when we're rushed, we'll make typos. But automation, it doesn't. It gives you the exact same outcome with zero chance of skipping tests every single time.
Section 1, Core GitHub Actions Vocabulary.
So if you're new to CI/CD pipelines, these terms can actually be incredibly simple if we use an analogy. Think of GitHub Actions like a highly efficient commercial kitchen assembly line. Best part, it's built right into your repository, so there's no separate server needed. The workflow is your entire kitchen process, from start to finish. The trigger, that's the order coming in from the customer, so a code push or a pull request. A job is a specific station in the kitchen, like the prep station or the grill. The runner is the actual physical counter where the work happens, a fresh virtual machine. A step is a single task, like chopping onions. An action is a prepackaged tool or ingredient you just drop in. An artifact is the finished dish that gets moved from the cooking station to the serving station. And a secret? Well, that's the highly classified secret sauce recipe, locked safely in the manager's safe.
Section 2, Building the Workflow YAML.
Okay, so every workflow actually lives in a hidden folder in your repo called .github/workflows/. Let's break down the core anatomy of this YAML file into 4 logical blocks. First up, the trigger. On push just means this pipeline runs every time someone pushes code. Simple enough? Second, the runner. Runs on Ubuntu latest. Tells GitHub, hey, spin up a fresh, fast Linux virtual machine for us. Third, the action. Uses action/checkout. This is a pre-built automation that grabs your code. And finally, the command, run pytest. This just executes a raw shell command to run your tests. See, we're really just stacking these simple blocks together. But hold on, there is a massive warning here. Never ever forget actions/checkout as your very first step. People forget this all the time. You gotta remember, GitHub spins up a completely fresh, brand new virtual machine for you. If you don't explicitly tell it to check out your repository, that runner is just an empty box. It has literally zero access to your code, and your pipeline is going to fail instantly.
Section 3, Controlling Parallel Execution Flow.
Now, there's a default behavior here that catches almost every beginner off guard. If you write a workflow with a linting job, a testing job, and a deployment job, GitHub is going to start all of them in parallel, right at the exact same time on completely separate virtual machines, which, yeah, is incredibly fast. But if you don't control it, your system might actually try to deploy your code before your tests even finish running. So to fix this, we create a dependency graph. Instead of parallel execution where everything just runs at once, we introduce this magic keyword, needs. By adding needs test to your build job, you're explicitly telling GitHub, do not start building until the tests have passed successfully. It forces the jobs into a sequential order. Going back to our kitchen analogy, the cooking station absolutely needs the prep station to finish first. If the prep fails, the cooking never even starts. This fail-fast approach saves compute time and, honestly, saves your team a lot of patience. Section 4, Managing Secrets and Artifacts. Listen, I literally cannot emphasize this rule enough. Never hard-code your credentials in your YAML file. Remember, this file is committed directly to your Git history. If you paste an AWS key or a database password in plain text, anyone with access to the repo can see it. And worse, it lives in the history forever, even if you try to delete it in the next commit. It is a massive, massive security risk. So what do we do instead? We use GitHub secrets. You just enter your passwords securely right into the GitHub UI. They're encrypted at rest, and they're only decrypted inside the running job when you explicitly call them using this exact syntax. $secrets.name. GitHub is even smart enough to automatically mask these values in your logs with asterisks if they somehow accidentally get printed. And for the pros out there, you'll definitely want to look into OIDC. That is the future upgrade path where GitHub Actions just assumes cloud rules directly, no stored passwords needed at all. Now, because these jobs run on completely isolated machines, files that get created during testing don't actually exist in the deployment job. To solve this, we use artifacts. It's a super simple process. First, you build and test your app. Second, you upload the finished package, like a .tar.gz file, as an artifact. And third, your deploy job downloads that exact artifact. This enforces the absolute golden rule of CI/CD. Build once, deploy that exact identical file everywhere. Remember our kitchen? Don't rebuild the dish at the serving station, you just move the finished dish forward. To keep track of all these artifacts, we use the GitHub context. Basically, GitHub automatically provides these built-in variables about the specific event that triggered the run. The absolute most useful one is $github.sha, which is your unique commit hash. By tagging your uploaded artifacts with this hash, you'll always know exactly which specific code change produced which specific deployment file. No more randomly guessing what version actually shipped 3 weeks ago.
Section 5. Caching and Pipeline Reveal.
Because our runners are completely empty virtual machines, they have to install all your project dependencies from scratch every single time. And you know, that is just slow and wasteful. But the fix is remarkably simple. For tools like Python, Node, and a bunch of others, GitHub provides built-in caching. Just by adding one single line, like cache pip, GitHub is going to save your installed dependencies. So on the next run, it just checks the hash of your requirements file. If the file hasn't changed, it instantly restores the cache and skips that whole slow installation process entirely. 16. That is the number of seconds saved in our basic example workflow just by adding that one single line of caching. It drops the dependency installation time from 18 seconds down to a blazing fast 2 seconds. And hey, when your team is running this pipeline dozens of times a day, those 16 seconds, they really add up to hours of saved developer patience and a ton of compute time. Well, we have covered some incredible ground in this explainer today. We started with that painfully tedious manual deploy, and we literally built a vocabulary, an architecture, and a secure workflow file that executes a flawless 62-second automated pipeline, all triggered by just a single push. So I have to ask, are you ready to automate your next deployment? Writing your own GitHub Actions workflow really isn't just doable, it is an absolute superpower for your development process. So what repetitive task are you going to automate first?